Hello and welcome. This is now the second part of the 8th session of the Comprehensive PLCLS training program with me, your instructor, Ali Izzat. In the first part of this session, we took the opportunity to get familiar with the different types of counters that are available. Now you will get more familiar with programming counters in the GX5000 software environment. Stay with us. Here we have entered the GX5000 software environment. It is important to understand that through this section, we can gain access to both functions and function blocks, mainly because counters are themselves also considered to be a type of function block. So we place it in the function block section. Now, the particular counter that we are going to want to use for this is the up counter. And as we have previously mentioned, this is represented by the abbreviation CTU. For instance, when we type the acronym CTU here and initiate the search, you will see that the system presents us with a variety of different modes to select from. For example, we have several different types of count-up or CTU counters, such as the CTU double integer, the CTU integer, and the CTU unsigned double integer, in addition to various other modes. And the key point is that all of these options will essentially be the same, whether you use a dual-sided setup or not. For example, here you can also clearly see both the CT and the INT. In addition to the other options, another significant data type is also available. Computed tomography, commonly known as CT, you can access and visualize these comprehensive datasets, which provide the detailed cross-sectional images necessary for a thorough analysis. Alternatively, if for example the count we need to track is a very high number, we have the option to use a larger data type, such as a long integer or even an unsigned long integer, to accommodate a wider range of values. Now, as you might recall, we have already become familiar with several standard data types, including integer, double integer, and long integer in some of our previous lessons. If you feel you need a more detailed refresher on this topic, you can always refer back to those previous lessons where we have fully and comprehensively explained those specific numerical ranges. For this particular demonstration, I am going to select and use the CTU, which stands for count up instruction with the integer data type. This means that it will count events for us, but it will be limited to operating within the standard integer range. Next, I will place this new counter instruction directly into the main organization block, which is often referred to as the OB, the primary block for program execution. At this stage, the software allows you to choose a specific instance name for your counter. For example, I will simply name it counter1, but you are free to enter any valid name that you want right here. As soon as we confirm this, you can now clearly see on the screen that the programming software has successfully created the counter block for us, and it is now ready for us to configure and use within our program logic. As we have mentioned, this first input pin is the count up trigger for the CTU block, and we will connect this input to a normally open contact instruction. Right here at this contact, you need to enter the specific hardware address of the input terminal where your physical sensor is actually connected. For example, let's suppose our sensor is connected to input number 0 of our PLC. In that specific case, we can enter the address ix0.0.0 right here to link this contact to that physical input. However, for today's lesson, since I want to demonstrate this using the software's built-in simulator environment, I will not use a direct hardware address. Instead, I will assign a memory variable here. For instance, I'll create a temporary variable named A, and I will set its data type to Boolean. The primary reason I have done this is so that we can easily toggle the state of this input manually while in the software simulator mode without needing any physical hardware connected.
Yeah.
Here, as we said, the reset input is connected to reset. Here we can use a variable, for example, named reset, whose data type is Boolean. Whenever this reset becomes 1, our counter resets to 0. Here we said you can enter its value. So we can input a number here. For example, I say let's enter the number 4, so our counter will count up to 4. Here we said save current value. Here we can use a variable, for example, let's call it save. Its data type is integer. We can input a variable here, or for example, use a coil. For example, here, let's use a coil and input it here. Its data type is Boolean, and whenever PV equals CV, this coil becomes 1. Okay, now let's go into the simulator and test this together. If I toggle this contact every time, the counter will counter by 1 for us. So here we need a pulse. Here I set its value to 0. If I toggle it again, you'll see the counter increases by 1 more, but the output is still 0. Let's give it another pulse. The counter value becomes 3. Now, as soon as these two become equal, our output becomes 1. Now you see, if we give another pulse, its value becomes 4. When PV and CV become equal, our output is activated. The output will remain active until we reset it. If I set the reset to 1, you'll see our CV becomes 0 and the output deactivates. To continue, the reset value must be set back to 0 so we can keep counting. If I activate it again, our counter increases by 1, and in this way, we can use this counter. Now, the next counter we're introducing is the down counter, CTD. Let's search for it. Like the previous counter, it has different modes. I'll select CTD integer. Here, we can choose a name. I'll call it counter. Again, like before, we need a normally open contact where we can enter the sensor address. Here, I'll use a variable named B with a Boolean data type. Here, we said the load preset mode is from the same LD input. Its data type must also be Boolean. We'll set the PV value, let's say 4, and the same value is selected. This time, let's set it to 3. I'll enter the value 3. The CV this time is the current value, which we'll set to 3. Here, we can also use a coil. This time, I'll name it Q1. Let's go into the simulator and test this together. We said that in the down counter, you must first perform the preset. So first, I'll preset it once. You see the PV value is loaded into the CV. This must be activated. For each pulse we input here, the counter decreases by 1. You see the value is 3 with 1 pulse. Now with the second pulse, the value becomes 2. And when the CV becomes 0, our output is activated. Now with 1 more pulse, the value becomes 0 and the output deactivates. If we do this again from the beginning, if we preset it again, the PV value is loaded into the CV and the output becomes 0, and we can repeat this process from the start. The next counter we're introducing is the up-down counter, CTU. If we search for it here, you'll see it brings up different modes. Select the integer mode and name the counter.
CTU.
Here, I'm using a normally open contact. CTU is related to the up counter mode. This time I'll name it start. CTU is a variable whose data type is Boolean. This part is related to our down counter. The important thing to note here is that in this section, we should not use a contact anymore. Here, we either need to use a variable or directly enter the address of the input from our PLC, which is the sensor related to the down mode, as the start address here. Or we can use a variable. For example, here we use a variable named, say, CTD, whose data type is Boolean. So here we can either use a variable or enter the address of the sensor connected to the PLC input. If we use a contact here, the software will give us an error. This part is related to our counter reset. We use R here, whose data type is Boolean. You can use any variable with any name you like here, as long as its data type is Boolean. When R becomes 1, our counter will reset. Next is the LD base. We said it has a preset state. I'll use the same LD whose data type is Boolean. Next is PV, which is our preset value. Here I'll enter the number 5, so our counter will count up to 5. CV displays the current value for us, so I'll use the same CV here. We said there are two outputs. One output is related to the up counter mode, and the other is related to the down mode. Here, I'll use a coil, for example, Q2, which is the output for the down counter mode. Here, we should not use a coil. Instead, we can enter the address of one of the PLC outputs, or use a variable, for example, QD, whose data type is Boolean. Here, we are not allowed to use a coil. Now our counter is ready. Now let's go into the simulator environment and test this counter together. For every pulse I enter in the CTU section, you'll see that our counter increases by 1. If I enter a second pulse, the value becomes 2. Now if I reset it, the value becomes 0. Now if I want the down counter mode to be activated, we said we must definitely preset it once. So if I set this LD to 1, you'll see that our PV value is inside CV. For every pulse we enter in the CTD section, which is related to our down counter, the counter decreases by 1. You'll see the CV value decreases by 1. If I create another pulse, you'll see the CV value decreases by 1 again. Now, in this state, if I give a pulse to CTU, let's see what happens. If I create a pulse here, you'll see the CV value increases by 1. So, as we said, the terminals related to up and down. If we create a pulse here, the current value changes. The last counter we'll test here is the range counter. If we press F17, we enter the function and function block section. We search for CTR. Here we can choose a name for it, for example, counter 4. This is related to our range counter. Here we can use a contact. For example, I'll use a normally open contact and define a variable, say CTR, whose data type must be Boolean. For every time this CTR is activated, the counter increases by 1. PV is the preset value. For example, I'll enter the number 4. Whatever value we want the counter to count to, we enter it here. This part is reset, and I'll use the same name whose data type is Boolean. Whenever this reset becomes 1, our counter resets to 0. CV is our current value showing the count, and Q is our output, which is Boolean. For example, I can use a coil and name it Q. Whenever PV equals CV, Q becomes 1. Now let's go into the simulator and test this together. For every pulse I enter in the CTR section, the count increases by 1. You'll see the value is 2 and the output is still inactive. The value is 3 and the output is still inactive. Now when the output becomes 4, CV is 4 and the output is active. The difference between this counter and the up counter is that if I enter another pulse here, CV starts again from 1 and the output resets. We can repeat this as many times as we want, so this acts as a one-shot for us. When PV and CV are equal, the output is activated. With another pulse entered in the CTD section, the counter automatically starts again from 1. And this can be very helpful in your projects. Thank you for your attention.